All right, in the next unit, we are going to take a look at rational expressions and equations. So first, we are going to revisit 2.8 and focus more on combining and composing rational expressions. So first, just our definition of a rational expression. It's just any expression in which a variable appears in the denominator. So something like 2 over x minus 3, we have a variable in the denominator. Now, something that would not be a rational expression would be like x plus 2 over 7, right? Where we have no variable in the denominator, because I could just write this as x over 7 plus 2 over 7, right? Or 1/7 x. So this is not an example of a rational expression, okay? We have to have a variable in the denominator. So let's jump right into an example here of adding, subtracting, multiplying, dividing, and composing two rational functions. All right. So whenever we are adding rational functions, the big thing is we need common denominators. Right? These are just fractions. So I need common denominators when I'm adding fractions together. In this case, I already have that. So all I do then is add the numerators together. So all I'm doing is combining like terms. 2x plus 4x would be 6x, and 3 plus -5 would be -2, and the denominator stays the same. Now we do also want to state the domain. So the denominator is the same all the way across, so the only value we would be excluding, right, because we can't have 0 in the denominator. So remember, whenever we had a fraction or a rational expression, we said whatever the whole denominator is can't equal 0. So I would just add the 2 over and say that x cannot equal 2. So when we're writing the domain, we would say we want every value except 2. So the way we did that, we said negative infinity up to 2, use a parenthesis to exclude 2, union, and then pick that back up at 2 and go to infinity. All right. Subtraction is very similar. Right? And again, we already have common denominators, so that makes this subtraction pretty straightforward. All I'm going to do is subtract terms in the numerator. But again, we have to make sure that we keep our signs straight. So I'm going to have 2x minus 4x. That would be negative 2x. And 3 minus -5. I've got a double negative there. So that would really be 3 plus 5. So that would be 8. And again, the denominator doesn't change. So the domain is going to be the exact same as addition. Right? It'll be negative infinity to 2, skip 2, and then 2 to infinity. All right? Now let's look at multiplication and division. So whenever we are multiplying fractions, I multiply the numerator and denominator together. Right? It does not matter if I have common denominators or not when I'm multiplying or dividing. In this case, we do, but that does not matter at all. Right? So when I'm multiplying here, I'm going to multiply every term in the numerators together. So 2x times 4x would be 8x squared, 2x times -5, negative 10x, 3 times 4x would be 12x, and 3 times -5 would be negative 15, over x times x is x squared, x times -2, negative 2 times x, and negative 2 times -2. And then we can simplify just a little bit by combining my x's in both the numerator and denominator. So we would end up with 8x squared plus 2x minus 15 over x squared minus 4x plus 4. Now, the domain, right, since again, my only factors in the denominator are x minus 2 and x minus 2, I could have just rewritten this as x minus 2 squared. The only value that would make the denominator equal to 0 again is 2. So my domain here is going to be the same as the last two parts. All right. Now, division. So I can write division a couple of different ways. So I'll write it as a complex fraction first. So this would be 2x plus 3 over x minus 2 over 4x minus 5 over x minus 2. Now, whenever I'm dividing fractions, that is just the same as multiplying by the reciprocal of the denominator. Okay, so this would really be 2x plus 3 over x minus 2 times the reciprocal of this times x minus 2 over 4x minus 5. Now, I've got factors that are the same in the numerator and denominator, right? I can cancel out those factors. Now remember, we can only ever cancel things out that are being multiplied. Okay? I'm multiplying those two factors. I cannot just cancel out terms that are being added or subtracted. But since these are entire factors, I can cancel them out. And I would just be left with 2x plus 3 over 4x minus 5. Now, the domain here, okay, we want to think about anything that ever shows up in the denominator, right? So the x minus 2's, even though they don't show up in my final simplified answer, they did show up in the denominator at one point. That means I still have to exclude the value of 2. But now I also want to look at this denominator, and I want to say that 4x minus 5 cannot equal 0. So I would add the 5 over, divide by 4, and we're going to say that x can also not equal 5/4. So the domain here has two values that need to be excluded. So I'm going to start at negative infinity, go up to the smallest one. 5/4 is smaller than 2. Exclude that. Union, pick back up with 5/4. Go up to the next highest value I want to exclude, which would be 2. Union, 2 to infinity. Okay, so the domain, whenever we're dividing, right, we want to think about anything that was ever in the denominator. We have to think about all of those values to exclude. So the last part of example 1, let's compose these two functions. Okay, so remember, this notation just means f of g of x. That means I'm going to take the entire function of g of x and plug that in place of x in f. So this problem is really going to be a lot of combining. We're going to have adding, subtracting, multiplying, and dividing essentially all in this one problem. So I'm going to take this entire function and plug it in place of this x and this x. So that's going to look like this. I'm going to have 2 times 4x minus 5 over x minus 2 plus 3. Right? That's my numerator. I just replaced x with this whole thing all over. And again, I'm just replacing x. So 4x minus 5 over x minus 2 minus 2. So now let's simplify. Let's distribute this 2 through. Now, this is really like 2 over 1. Okay? So when I'm multiplying this 2, and I'm only multiplying it to the numerator. So this would become 8x minus 10 over x minus 2 plus 3 over 4x minus 5 over x minus 2 minus 2. Now, to simplify this, let's make both the numerator and denominator a single fraction. To do that, we need to get like terms. So if I'm thinking about this as 3 over 1, to get common denominators, I need to multiply both the numerator and denominator by x minus 2. Okay? Same thing down here. To get common denominators, I need to multiply top and bottom by x minus 2. So when I do that, I'm going to end up with 8x minus 10 over x minus 2 plus, now I'm distributing this 3, so that'll be 3x minus 6 over x minus 2 all over 4x minus 5 over x minus 2 minus, and again, we're distributing this 2, so that'll be 2x. And then since I left that subtraction sign out front, we're thinking about this as 2 times negative 2, so minus 4 all over x minus 2. And then we can combine my like terms here. So 8x plus 3x would be 11x. Negative 10 plus negative 6 would be negative 16 over x minus 2. And that'll all be over. So 4x minus 2x would be 2x. And negative 5 minus negative 4 would be negative 5 plus 4. So minus 1 over x minus 2. And we just said that whenever I'm dividing fractions, that's the same as multiplying by the reciprocal. So this would really look like this. Now, since these are being multiplied, these x minus 2's are factors, I can cancel those out, and I would just be left with 11x minus 16 over 2x minus 1. Okay, so we talked about problems like this where whenever we're composing, we first need to find the denominator of the inside part. Okay, so the denominator of the inside part of g of x would just exclude x equals 2, right? Then we want to look at the domain of our final composition. So we want to say, well, 2x minus 1 can't equal 0. So add the 1 over, divide by 2, and we get that x cannot be 1/2. So again, to find the domain of a composition, find the domain of the inside part, also find the domain of the final composition. So in this case, we have 2 values to exclude. So our domain will be negative infinity up to 1/2, union 1/2 to 2, and union 2 to infinity. All right. So let's take a look then at a second example. Right? These ones will be actually a little bit trickier to add and subtract, but maybe a little easier to multiply and divide. Now, I mentioned before that we want to factor anything we possibly can. In these two problems, I can factor both of the denominators. X squared minus 9 would factor into x plus 3 and x minus 3, because that's a difference of squares. And here, if we x factor the denominator, right, we want 2 values that multiply to negative 6 that add to negative 1. Well, I think that would be x or positive 2 and negative 3. So I can write this as x plus 3 over x plus 2 times x minus 3. So now, when I'm adding these, again, we said we need common denominators. So let me rewrite this. X plus 2 over x plus 3 times x minus 3 and plus x plus 3 over x plus 2 times x minus 3. For the denominators to be common, we need all the same factors. Now, both of my denominators already have a factor of x minus 3. So, to get common denominators here, I just need to look at the other factor, right? I would need to multiply this by x plus 2 over x plus 2, and I would need to multiply this by x plus 3 over x plus 3. So, if I do that, I'll have x plus 2 over x plus 2, and over here times x plus 3 over x plus 3. Now I can multiply these out. I would have x squared plus 4x plus 4 all over, and now usually we say it's acceptable when we're adding and subtracting to leave the denominators in factored form, because I know I'm not going to be combining anything in the denominators. But we do multiply out the numerators because I'm going to be able to combine like terms here. So here I'll have x squared plus 6x plus 9 over that same denominator, x plus 2 times x minus 3 times x plus 3. And then if I combine like terms, I'll have 2x squared plus 4x and 6x would be 10x, plus 4 and 9 would be 13, all over x plus 3 times x minus 3 times x plus 2. All right. Now, as far as the denominator, right, we have three values that would make the denominator equal to 0. Right? We would have -3, -2, and +3. So I need to exclude those three values. So I would say -infinity up to -3, skip that, then go -3 up to 2, skip 2, and go 2 to 3, skip 3, and go 3 to infinity. All right. Subtraction is going to be very, very similar. So it's actually, we can pick it up right here at this step, right? So you take this step here and put that into the next problem. All right, so, oops. But instead of adding, I'm just going to be subtracting. All right, so make this a big old subtraction sign. And I would say x squared minus x squared is just 0. 4x minus 6x would be -2x, and 4 minus 9 would be -5, all over that same denominator. X plus 3 times x minus 3 times x plus 2. And the domain would be identical as the addition problem, so I'm not going to waste time writing it out here. I do want to look at the multiplication and division parts of this, though. All right, so I already have the factored forms up here. We don't need to refactor. So when I'm multiplying these functions together, I've got x plus 2 over x plus 3 times x minus 3, and x plus 3 over x plus 2 times x minus 3. We just talked about, since I'm multiplying straight across here, I can cancel out any common factors. I see an x plus 2 in the numerator and an x plus 2 in the denominator. I can cancel those out. I see an x plus 3 in the numerator and an x plus 3 in the denominator. I can cancel those out. And I would just be left with, then in the numerator, I would just be left with 1 over x minus 3 times x minus 3. Well, that would just be x minus 3 squared. Now, we do want to be careful, though, in terms of the domain. We need to think about anything that was ever in the denominator. So my domain is still going to be the same here as it was. I need to exclude -3, 2, and 3. So it'll still be -infinity to -3, union -3 to 2, union 2 to 3, union 3 to infinity. All right. Now, division. Again, we said division is the same as multiplying by the reciprocal. So I can write this as x plus 2 over x plus 3 times x minus 3 times the reciprocal of the denominator. So that'll be x plus 2 and x minus 3 in the numerator now over x plus 3. Now, if I look at factors, the only things that I can cancel out are the x minus 3's. I've got one in the numerator, one in the denominator. So I then get x plus 2 times x plus 2 over x plus 3 times x plus 3, right? So now the domain, again, we need to think about anything that was ever in the denominator. So one thing that could change, right, if this numerator that became a denominator here was something other than x plus 3, that would also need to be included in the domain of the division problem here, right? But we already accounted for this factor over here. The domain is actually just going to be the same as what it's been for the last few problems. I need to exclude negative infinity up to negative 3, union, negative 3 to 2, union 2 to 3, union 3 to infinity. Okay, I need to exclude anything that was ever in the denominator. All right, so these two would actually be a lot of work to compose. So I put one final composition problem on here. So let's run through this one real quick. So again, f of g of x means I'm plugging the entire function of g of x in place of x in f. So that'll look like this. I'll have 3 over, and this x is getting replaced by 7 over x plus 4 minus 5. So I want to combine my denominator here into a single fraction. So I'm going to multiply this 5 by x plus 4 over x plus 4. That'll get me common denominators, right? And again, we're thinking about this as over 1. So if I do that, I'll have 3 over 7 over x plus 4 minus, then 5 times x is 5x, 5 times 4 is 20 over x plus 4. Now, be careful here, okay? I left my subtraction sign out here, so then I was really just taking 5 times x and 5 times 4. You could have taken negative 5 times x and negative 5 times 4, but then this would become an addition sign, right? So whichever way works best for you. Then in the denominators, when I combine, I'll just have negative 5x, and 7 minus 20 would be negative 13 over x plus 4. And then I would be multiplying by the reciprocal. So 3 is the only thing in my numerator, right? Well, we can really think about that as 3 over 1 times the reciprocal here. So times x plus 4 over negative 5x minus 13. And then when we're multiplying, we multiply straight across. So this would be 3x plus 12 over negative 5x minus 13. Now, for the domain, the first thing we need to think about is the domain of the inside, right? In this case, the inside is g of x. So I want to look at the denominator here and say, well, what values would make that denominator equal to 0? That one is pretty easy, right? We would just get x cannot equal negative 4. And then I want to think about the denominator of my final composition. So we also want to say negative 5x minus 13 cannot equal 0. Add the 13 over, divide by negative 5, and we'll get that x cannot equal negative 13 fifths. So two values I need to exclude. Negative 4 is less than negative 13 fifths, so that's what I would start with. That's the first value I would exclude. So I'll go negative infinity to negative 4, union negative 4 to negative 13 fifths, union negative 13 fifths to infinity. All right, that is it for this lesson. The final question is going to pop up asking you what questions you have.